Alrighty, we're back with another algorithm video. In this video, we're going to be trying to find two numbers in a given array that add up to the target number, which the user will give us. Alright, so here in this example, we have the data set 2, 7, 11, and 15. Our target number given by the user is 9. So we go through and find two numbers that add up to 9, which luckily it's 2 and 7, the first two. So we return 0 and 1 because we're returning the indices, not the actual data points. Alright, so what we have to do and clarify right now is that we're going to have a hard-coded data set, meaning in our code here, we're just going to push in a bunch of numbers. I pushed in 21, you can do however many you want, but you gotta remember that number. So let's actually talk about the algorithm now. The first step of the algorithm is to find all the numbers in that array that are less than the target number. So here is an example of this. We go through this data set 3, 2, 5, and 4 and find all the numbers that are less than 4. What we do with those numbers is we create objects of this struct that we will create called addEnd, and an addEnd is just one of the numbers that adds up to a different number. So we have this struct, it holds the data value and the index number. So here we would find 3 and 2 are less than 4, so for each one we would create a new object. So 3 would have the data value of 3 and the index number of 0, and then we push that into a new vector. And we do that for 2 as well. So that's what happens in the first step of the algorithm. In the second step, for each one of those new elements, we're going to loop through and use this equation as target minus the data to get the other addEnd that we have to find. So the equation in this example would be 4 minus 3 is 1, so we have to look for 1. If there is a 1, 1 plus 3 equals 4, so we'd return those indices. If it's not there, then we move on to this one, and 4 minus 2 is 2, so we look for 2. That's how this algorithm works. Let's look at a concrete example. So here we have the target number equals 5, and our data set is equal to 3, 2, 5, 4, 6, 2, and 7. Our first step is to find all the numbers that are less than 5. So we do that. We set new objects and push them into a vector. So this is the result from the first step. In the second step, we loop through each one of these until we find the answer, of course, and we use this equation, the target, which is 5, minus the data in this first node is 3, and that equals 2. So we're looking for x, which is equal to 2. So we go through all these, skipping this one because we don't want to use the same index twice as our answer. So we skip that one and we look here, and 2 is the value and we're looking for 2, so we return this number, which is the index number, and this number, which is the index number. Alright, that's how it works. Let's go ahead and look at the code. So to start off, here's a header file. I only have one header file. It's addEnd, I couldn't speak, addEnd.h, and all we have is a int variable of data and index, and that's all it does, and we have a constructor that sets those. Alright, that's all that is. Let's look at the actual program now. We have our main. We are including the vector library, the IOStream library, and our header file that we created. Like I said earlier, we hard code an array to have a bunch of random values. Specifically, there are 21 values here, and then we have 3 variables of type int. We have index 1, index 2, and these are going to be our results from the actual method. And then we have our target, which we get right here from the user. Alright, and then we call the function passing in the dataset array, which is here. We pass in the size of the dataset array, so we know how many times to iterate through it. And then we have the target number that the user gave us and the 2 indices that will be our result. Alright, and then we go to the function, the actual meat and bones of this program and problem. We first start off by creating a new vector, and we set the type as addEnd, and we're using pointers, and then we call it less than. And then we have a flag here of type int called found, so this will change to 1 when we find two numbers that add up to the target. And that'll break the loop. So our step 1 is to find all the numbers that are less than. So what we do is we take that size that we pass in as our second parameter, and we set that as the condition. And then we loop through all the points in the array and check if they're less than the target, and if they are, we create a new pointer at end, and we set the values and the index, and we push it into that new vector. That's step 1, that's all it is. That takes O of n time, and then for step 2, which takes O of n squared time, worst case, we have to do some nested loops here. So our first loop loops through the vector, and with vector we have an actual size function, so we can just use that. So this is going through every element in the vector, less than, and then we say if found is equal to 1, then we break, because we already found our answer. We don't want to keep looping through. We don't want to waste more time than we need to. And then else, we're going to do all this stuff. So what we do in here is we find that integer from that equation, target minus the data value, and that's what this is, target minus less than at index I data. And since we're using the pointers, we have to use this arrow instead of the dot operator. And then we loop through again the vector less than, trying to find that number. And if this is our skip statement, so if j is equal to the I index, then we just jump over that index because it's the same one that is our other add-in. Otherwise, we'll go in here and check if the values are equal, and if so, we return the indices and set found equal to 1 so it doesn't keep going. Alright, and then one thing, I made a comment down here, you could go through and delete all those add-ins in the vector just to free up memory space, but we would really only do that if there is other code, we were doing other things in this program. But since the program will terminate after all this happens, the memory is freed anyway. So back here, we simply see out both indices, and then we'll check if that's right. We're going to do the same as the last video and compile this in the command prompt. So in Windows, you type in CMD in the search bar, or I just got it pinned to my taskbar. We're going to open that file in which the source files are located. So here are my source files right here. I'm going to click up here in this bar and Control-C to copy it. I'm going to go back to the command prompt, press CD for change directory, and then paste that path in there, and this will take me to that folder. Alright, if I do dir, for dir for a directory, it shows me everything that's in here. I have all the junk from Visual Studio when it compiled. I have an actual executable when I was testing this earlier, and I have my source files. So what we're going to do, let me see if I can remove this runme.exe. Alright, so I'm gonna go ahead and remove this exe so I can show you how we do this with the del delete command, just like so. Now if I show you again, it's gone. Now we're going to compile this with the G++ compiler, the MinGW compiler. And if you don't know what that is, I will hopefully be making a video about it soon, and if I don't, well, you can look it up on YouTube. So what we're going to do is type the command G++, that's our compiler, and then the flag O for object because we're creating an object, and we're going to type in the executable name that we want, and we're going to pass in the files that are going to be compiled into it. Alright, so we just have, actually we don't even need to do the header files because it's linked through the main CPP. That's all we got to do. It'll compile, and when it's done, we'll go ahead and run it simply by stating the runme.exe. Alright, let's do that. Run, and if I show you, there it is. It's located right there. And we'll go ahead and run this. There we go. It asks for the target. We'll say we want 12. So it says 12. The add-ins are located at position 0 and 13. So if we look at our code here, this is position 0, 11, and if we find 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 11 plus 1 is 12, and let's see what we put in. I said 12, so that's good. It works. All right, we could do this for any number. I could run it again and do 5. It'll give me different numbers. So that's that problem solved. Hope you guys enjoyed. Try this on your own for sure, and catch you in later.